world, you're welcome to lesson 2 of the journey. That's becoming a programmer. In this lesson, we're going to talk about algorithms and pseudo-codes. I call this the programmer's way of thinking, simply because when you're being given a problem to solve, the way you go about solving the problem, you actually think of it, you sequence your logic, and then you end up writing a program to solve it. And that's why I call it programmer's way of thinking. By the end of this lesson, you should be able to define what an algorithm is, write simple algorithm, you should be able to draw flowchart representation of an algorithm, write pseudocode representation of an algorithm. You should be able to state and explain at least 2 programming methodologies. Let's begin. What is an algorithm? Now, I'd like you to think about an algorithm to be a series of steps that you follow to do something, or let's look at a recipe for preparing food. When you are being given a recipe to prepare food, there are instructions as to how to go about to prepare that kind of food. This is what an algorithm is. It is a set of well-defined, unambiguous steps or instructions to be carried out in a sequence to accomplish some task. In programming, when you have a problem, you think about how you are going to solve it. You sequence it step by step, and in following that algorithm, you end up solving that problem. So if you give the algorithm to another programmer, the programmer can follow it and then write a similar program that will output the same result. Now let's break an algorithm down. First of all, an algorithm should have a start and then a stop. There is always a beginning and then there is an end. And then algorithm is made up of individual set of instructions. Okay, so you may have step 1, step 2, step 3, step 4, step 5, until you get to end the algorithm. Each instruction is well-defined operation. All the instructions within an algorithm should not be ambiguous. In other words, they don't contradict each other. So if you are following it, a sequence and tells you after this step, you move on to another step. There is always a predictable outcome. When you follow an algorithm and then you use it to write a program, that program that you have written will produce a certain result. Now, if another programmer uses that same algorithm to write that program, when you input the same data, you are supposed to have same result. So just like the recipe, maybe a recipe for preparing jollof rice, you go through the whole recipe and then you end up preparing something that looks like rice balls. Then there are 2 things wrong here. Is it that the one who is preparing couldn't follow the instruction very well, or the instructions are ambiguous? The next thing is The next thing is direction of logic flow or sequencing. An algorithm, where you have a step. A step will tell you where to go next. And when you're done with that step, it tells you where to go next. You have finite set of instructions. So you may not have instructions that are endless, and then you wouldn't even know whether you're going to end or not. Just similarly to the recipe, okay? You will have finite set of instructions, and these instructions, when you are done, you get an output. An algorithm always terminates or stop in an expected way. So if you have followed an algorithm and then you've written a program and you are running this program and then it quits or gives you a certain result, or the program quit unexpectedly, then you need to know that something is wrong with the program or the design of the algorithm. Maybe after doing this calculation, you should always get to the stop symbol. Your program shouldn't terminate unexpectedly. So in flowchart, how can we represent an algorithm? You have the start, and you have series of steps, step 1, step 2, step 3, and then you will have stop. As simple as that. But a flowchart has 5 symbols. Okay, the first one is over, which denote the beginning or the end of a program. The next one is a flow line, which denote the direction of logic flow in a program. So you will see this line telling you where to move next. And then when you see A parallelogram, it denotes an input operation or an output. This is what you use to display if you want to display anything, or this is what you use to take an input from the user. And then you have rectangle, which denote a process that is to be carried out. You also have the diamond. Lastly, you have the diamond to denote a decision or a branch to be made. Okay, so if you have any decision where you want to make within your flowchart or your algorithm design, then you use the diamond to do that. In pseudocode, it is simple. You have a step, start, move to step 1, move to step 2, move to step 3, and stop. You have the start and then the stop. Now think about pseudocode to be a shorthand notation for programming, which uses a combination of informal programming structures and then verbal description of code. You may have series of English or description of what you have to write as part of the pseudocode. For instance, you have a pseudocode to be this: start, output, enter a positive integer, input n, assign 1 to I, or I is equals to 1, while I times I is less than n, the number you inputted. What you have to do is that you have to increase it by 1 by doing I is equals to I plus 1. And then you check the condition again until this condition becomes false. So then you move on to the next statement. If I times I equals to n, the number you inputted, is your output yes, else your output no, and then you end if. That is, you are ending the if statement that you open, then you stop. That is a simple pseudocode. So let's look at an algorithm here that I designed for the purpose of this course. I call this the coconut milk algorithm. I got this recipe from foodviva.com. Okay. All right. The coconut milk algorithm. Milky white coconut milk is used as cooking base in many recipes as main or flavoring ingredient. The rich and creamy texture of coconut is attributed to high oil content in it. This oil-rich milk simply transforms any seafood recipe into a lip-smacking recipe. We prepare this every last Sundays in the month for our family get-together. Now, the preparation time usually takes 15 minutes, and then by the end, you will be able to serve 2.5 cups milk, and then the ingredient used 1.5 cups grated fresh or dry coconut, 1.5 cups hot water. These are the ingredients. Now, where I want you to pay more attention to is the direction. First of all, you have the start of the algorithm. The second step says get the ingredients. Third, take fresh grated coconut in a bowl, pour hot water over it, and let it stand for 5 to 7 minutes. Water should not be boiling hot. Place mixture in a blender and blend until smooth puree. Strain it through cheesecloth or sieve. Step 7. Keep strained liquid in refrigerator and use within 2 to 3 days after preparation. 8. Pour prepared milk in ice tray, freeze it, and then store frozen milk cubes in plastic bag in freezer for 1 month. 9. Use it as an ingredient to prepare smoothie, milkshake, curry, sweet, desserts, etc. It can also be used for seafood, crustaceans like shrimps and lobster, and fishes, stews, and desserts. Now, step 10, clean up dishes. Step 11, end of algorithm. Now, when you study this algorithm, it tells you in precise what you have to do. For instance, look at the step 4. Say pour water over it and let it stand for 5 to 7 minutes. Okay, and then step 7 says keep strained liquid in refrigerator and use within 2 to 3 days after preparation. So when you follow this algorithm, you're actually going to prepare a coconut milk. Yes, you can do it. Yeah, like I said, I got it from foodfever.com.